Hello, this is Mr. Henry, and welcome to lesson 2.6, the distance formula, using Pythagorean theorem. This essential question says, how do I apply the Pythagorean theorem to find the distance between 2 points in a coordinate plane? So remember in the last lesson I told you how pretty much the Pythagorean theorem is used to find a distance between two locations. Well, here it is. We're finding the distance between 2 points, but this time it's in a coordinate plane. And the warm-up says for you to summarize what you've learned about the Pythagorean theorem in a few sentences. So you should probably have things like, well, Pythagorean theorem is used only on right triangles. It can be used to determine if something is a right triangle by using the converse. That was the very last lesson we just did. You might say that the converse is used to find the one missing side of a right triangle if the other two sides are known. The Pythagorean theorem can be used to find distances in real life if a right triangle could be drawn. Those are just a variety of different things you might have said about what the Pythagorean theorem is used for, what you've learned. You learned it's a squared plus b squared equals c squared, where a and b is the hypotenuse, and a and b are the legs, and c is the hypotenuse, and that the hypotenuse is always diagonally across from the right angle. So, new vocab word, distance formula. The distance formula, as you can see, it looks pretty ugly. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, that formula looks really ugly, and you probably are going to hate to have to memorize it. The good news is, you pretty much don't. You don't have to memorize that formula and able to use it. The one formula you have to memorize to do it is, you guessed it, the Pythagorean theorem. That formula you see there is just the Pythagorean theorem written in another way, in the context of a coordinate plane. So the first thing I have on the note sheet here is, why does the distance formula work? And I have an example here. I have 2 points A and B. Point A is this guy down here. Point B is this guy up here. Now, I want to show why this distance formula works and how it's related to Pythagorean theorem. So if I take and I connect these 2 points with a straight line, or straight as possible, it's going to go through there, close enough, and over and up. That is a right triangle. Hopefully you can agree. Now, the length of this side is 2. The length of this side is 1, 2, 3, 4. So if I would use the Pythagorean theorem, a squared plus b squared equals c squared, this is the hypotenuse, so I don't know that side. A squared is 2. B is 4. That gives me 4 squared, 2 times 2 is 4. 4 times 4 is 16 equals c squared. 20 equals c squared. If I square root each side, c equals 20 square root 4.47 is the length of this side. Now, that is using the Pythagorean theorem. That's not using the distance formula. Let me show you what we would do in the distance formula. So the distance formula between here and here is honestly, it is using this Pythagorean theorem. It's just written in another way. If you can do this, and this works for you, fine, use it. If you can't do this, then maybe or if you want to know the distance formula, it might be a little bit quicker maybe. So the distance formula says the square root of, that's this square root that's happening here, x2 minus x1, which is the x value of the second point, minus the x value of the first point, squared. So it's finding the distance from here to here. This distance, that's the change in x. The change in x. So you're taking 2 squared. Looky, 2 squared plus y2 minus y1 squared. That's the y value of the second point minus the y value of the first point. What you'd find, well, let's do it. x2 minus x1, so 3 minus 1 squared is 2 squared. That's this 2 squared right here. y2, oopsie, wrong space. y2 minus y1, 5 minus 1 is 4 squared. That is literally this 4 squared right here. It's the distance here, the change in y. And let's not forget our square roots everywhere. 2 squared is 4 plus 16. Square root of 4 plus 16 is 20. And the square root of 20 is 4.47. So what we found the distance formula does, it's just another way of rewriting the Pythagorean theorem, but using coordinates. If you can do this math, you can find the change in the x values and the change in the y values. You might find this to be easier, and it's one less thing you have to remember. But the distance formula is there if you need it. And once you have the formula, you can simply just plug the coordinates from an ordered pair directly into the formula, and it does all the work for you. You don't even have to think anymore. You just pop them in there, and it spits out an answer. Okay? So that's okay that the distance formula looks ugly. We now know it's really just the Pythagorean theorem written in another way. Example A. What is the length of the segment that goes from 4, 2 to -3, -4? So the distance formula, x2 minus x1 squared plus y2 minus y1 squared. So I'm going to use the distance formula in this one here, just to show. So I'm just going to plug in the numbers from the problem. So this is the first point in the problem, so I'm going to call this the x1, y1. That's the x coordinate of the first point, the y coordinate of the first point. This will be x2, y2. Same thing. The x coordinate of the second point, the y coordinate of the second point. That just helps me when I'm plugging my values into my formula. x2 minus x1 squared plus y, oopsie, I messed up. x2 is -3. x2 minus x1 squared plus y2 minus y1 squared. That gives me -7 squared plus -6 squared. 49 plus 36. Um, 49 and 36 is 70, 85. So D is, the distance is, just let me double check this, 49 plus 36. 49 plus 36, there we go, square root that thingy, gives us 9.21. And there is the distance using the distance formula. Now, you're thinking, but Mr. Henry, I hate the distance formula. Can I use the Pythagorean theorem still? I'm good at that. Well, maybe. Depends on how good you are. Well, let's see here, letter B. I'm going to try to use the Pythagorean theorem, and if you don't like it, I'd suggest you go and start using this distance formula. So it says, what is the distance from point A at -5, 2 to point B at 1, -4? So you have to find out how far it is from here to here. What is the distance between these two? Well, the distance between -5 and +1, I know the distance is 6. There's 6 numbers between -5, and +1. I guess the way that I would recommend you do it is take, just like in this distance formula, take this number minus that number. 1 minus -5 gives you 6. That's how far it is between those two. Between these two, -4 minus 2 can give you a -6. Well, the distance between here is 6. And so since you know this change in x is 6 and the change in y is 6, you would basically have a right triangle with 6 and 6 as your sides, and you'd want to find that. Think to yourself, are you finding this easier than plugging the numbers into the formula? Maybe. A squared plus b squared equals c squared. 6 squared plus 6 squared equals c squared. 36 plus 36 equals c squared. 72 equals c squared. Yes, I went fast, but that's just plugging numbers in and multiplying and stuff. Yeah. Square root each side. C equals, calculator says, 8.48. And looking at my answer key for the same problem, I got the exact same answer on my answer key. I used the distance formula. So you can decide. Do you like the distance formula, or do you like Pythagorean theorem? Pythagorean theorem takes a couple extra steps ahead of time, so you can find out what these values are. Or the distance formula kind of does it all in one big ugly formula, but it gets it all done for you. So here's what I'd like you to do. I'd like you to do letter C right now. Pause the video, try it on your own, either using Pythagorean theorem or distance formula. I don't care. Do it one way or the other, or maybe try both. But pause the video, do it, and when you're ready to continue, hit play, and we'll go through it together. Okay, so let's see here. We'll use green. I'm going to start with the distance formula. Distance formula says the square root of x2 minus x1 squared plus y2 minus y1 squared. And so x1, y1, x2, y2, because these are my first points, they get 1s. This is my second point, they get 2s. It honestly doesn't make a difference which way you do it. Just pick one and stick with it. x2, -9 minus 0 squared plus y2 is 12 minus 0 squared. The distance is the square root of, that is going to be -9 squared. That is going to be 12 squared. 81 plus 144. 81 plus 144. 225. And so that distance is 15. So the distance between those 2 points on the coordinate grid is 15 units. Now, if you're choosing to use the Pythagorean theorem, and you have your little right triangle drawn, the distance between the x points from here to here is 9 units. Notice the distance is always positive, 9. And the distance between here and here is 12 units, so this would be your missing piece. And then you do your 9 squared plus 12 squared equals c squared. Look, see? That's that step right there. 9 squared is 81 plus 12 squared is 144 equals c squared. That's that step right there. And then you take 81 plus 144 is 225. That's that step right there. Equals c squared. And then you square root each side and get c equals 15. And that's that step there. So you see, it really is Pythagorean theorem. the same steps, the same order, nothing changed. It's just a different format. Letter D. Now here I have just two random points. Now I have a coordinate grid, so I have x and y axis and stuff. And I want to find out what is the distance between these 2 points. I personally find in problems like the previous problems, like this, where they just give me points, I personally would use the distance formula. I would find the distance formula a little bit quicker and easier. But in a problem like this, I personally would use the Pythagorean theorem. Because on a picture like this, I can draw in. Here is my change in y. Here is my change in x. I'm kind of drawing in here. And there's the side I want to find. So this is a right triangle. This side is 3 units big. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7 units long. And I want to find that. That, to me, is going to be quite a bit easier than using the distance formula. So here, I would use Pythagorean theorem. And this C is the hypotenuse, and I don't know that. 3 squared, 7 squared gives me 9 plus 49 equals C squared. That gives me 58 equals C squared. And then I square root each side, and I get C equals 7 point something. 58 square root 7.6 is the length of this side. Alright. Now, if you chose to use the distance formula, this is the ordered pair. This point has a coordinates of 3, 1. This point has the coordinates of -1, -2, -3, -4, -2. And so you'd plug that in. Distance equals x2 minus x1 squared plus y2 minus y1 squared. The distance is the square root of x2. Just for fun, I'm going to call this guy my x1, y1, x2, y2. So x2 is 3 minus -4 squared plus 1 minus -2 squared. 3 minus -4 is positive 7 squared. 1 minus -2 is positive 3 squared. And so now we are here. 7 squared is 49, plus 3 squared is 9. We are here. Add these together, you get your 58, and then you square root both sides like it says, and D still equals that 7.6. Alright, so there's Pythagorean theorem, there's distance. I would personally, in a problem like that, Pythagorean theorem, because I can draw the picture, make the right triangle. It makes sense to me, it's easy for me. 7, 3, boom, got myself an answer. Here's one for you to try. This is letter E. Go ahead and make sure you place the dots properly on your paper. That's a big mistake for problems, is just not copying the problem down correctly. So make sure the points are correct on your paper, and then do the problem for yourself. Pause the video when you're ready to continue, hit play, and we'll go through it together. Alrighty, here we go. So again, I personally am going to use the Pythagorean theorem. So down 1 over that many, and I'm going to cheat to make sure my line is straight here. I'm going to go from here to there. Ain't that beautiful? Alright, so we've got, this is a distance of 1, this is a distance of 1, 2, 3, 4, 5, 6, 7, 8, 9, and I do not know that side. Mr. Pythagorean theorem can help us out though. C is the thing I'm trying to find. That's my hypotenuse. It's going to stay a C. The other two sides are 1 squared plus 9 squared That gives me 1. That gives me 81. That gives me 82. 81 plus 1. And then I square root each side, and I find C is equal to, it's going to be just over 9, like 9.1 something. 82 square root, there you go, not even 9.1, 9.05 is that distance. Example 2. The city of Mathtopia is set up with roads that make a coordinate system. The library is located at corner of -3, 5 street, and the bank is located at the corner of 9, 10 street. What is the distance between these 2 points if you could fly over the buildings? Okay, so this is again using coordinate grids, finding a distance between these 2 locations. I mentioned before, because it's giving me a word problem, I'm probably going to use I am going to use the distance formula. So it's the change in the x value, the difference in the x squared, plus the change in the y value, or the distance between the y coordinates, squared. This is the left-right distance. This is the up-down distance. So, let's see here. We've got x1, y1, x2, y2. That's the first point I got in the problem. That's the second point. 9 minus -3 squared plus 10 minus 5 squared. That gives me 9 minus -3 is a positive 12 squared. 10 minus 5 is a 5 squared. Twelve squared is 144. 5 squared is 25. That gives me 169. This might be familiar. We get the answer of 13. That was the 12, 5, 13 right triangle we've seen quite a few times now. Oopsie. 12, 5, 13 right triangle. So the distance between those 2 places, the library and the bank, is 13 units straight flight over the buildings. So if you went, that's terrible, but 12, 5, and 13. So from here to here is 13 units. Letter B. What is the distance between your house and your friend's house according to the map? So the map I have right there, what is the distance between your house and your friend's house? Go ahead, pause the video, and try it on your own right now. Okay, so I personally would use Pythagorean Theorem here because I have a picture, I can count boxes. This is 2 units this way. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units this way. And there's the diagonal distance. And since I know this is a right triangle, I can use Pythagorean Theorem. A squared plus b squared equals c squared. 2 squared plus 10 squared equals c squared. I'm just plugging in. This is my hypotenuse over here. It's still a variable. This math gives me 4 plus 100. 4 plus 100 is 104. And if I square root each side, c equals 104 square root 10.198. We'll make it 10.2. If you did the distance formula, you should get the exact same answer, just a different method. Okay, not bad. That was pretty easy. What about this guy? It says a container ship must travel from China to Long Beach. How much fuel would be needed if the ship gets 100 miles per gallon? So what I have here in the picture, these are the latitude and longitude of these locations. And so the latitude and longitude on the Earth is sort of like a coordinate grid. And we want to know how much fuel would be needed if a ship gets 100 miles per gallon. Now, to do that, we need to figure out, first off, what is the distance? Because think about it, the distance you travel, the amount of fuel you need, depends on how far you go. If you go 1 mile, you don't need much fuel. If you go 1,000 miles, you need a lot of fuel. So we need to find the distance between those two cities in order to find out how much fuel we're going to need. And the way we can find the distance between those two cities using latitude and longitude is, you guessed it, a little Pythagorean theorem. Now, this one, I don't have a coordinate grid. I can't count boxes, so I'm probably going to use the distance formula here. I'm going to do it down here. I don't want to run into this space here. So distance formula, over here. Distance formula is the change in x squared plus the change in y squared. x2 minus x1 squared plus y2 minus y1 squared. Distance is, so this I'm going to call it as point 1. Try it again. y1 x2 x y2. My goodness, my brain's not working. x1 y1 x2 y2. All right. x2 3490.8 minus x1 is negative 3414.8 squared plus y2 2331.5 minus y1 2152 squared. Alright, so calculator is going to make this next line quite a bit shorter. So 3490.8 plus, because minus a negative is a plus, 3414.8 equals 6905.6. 6905.6 squared. So that is this value. On the other side, we've got 2331.5 plus minus 2152 179.5 squared. Don't forget our square root. Alright, getting there. We're narrowing it down. We've got to square both of these, add it together, and square root. So let's square them. So this 179.5, wrong one, 179.5 squared 3222 0.25. So 32,220.0525. And the other side is 6905 back 905.6 squared. Oh, ain't that lovely? 47,687,311. Okay, take that plus our 32,220.25, and calculator, don't crash on me. Oh, I guess I should write that in. 47719, 47719.532. My 0.25 disappeared. I'm guessing he's still out there, but he got rounded off, I think. I ran out of space. And square root 6907.9. The square root of that, so the distance is 6,907.9 units. And those units in this case will be miles. So the distance between this city in China and San Francisco is 6,907.9 miles. So we've found a distance between those 2 points. We can now use that distance to find out how much fuel we need. Because if this boat is traveling, here's a little boat, a little steamboat, whatever. So if that boat is traveling across the ocean here, and it gets 100 miles per gallon, how many gallons of fuel? How much fuel would you need? Well, if it gets 100 miles per gallon, so every 100 miles is 1 gallon, how many hundreds of miles is this? 6907.9 divide by 100, because you're trying to find out how many hundreds of miles, and the answer is it's 69.079 100 miles. In this case, you're going to need 69.079 gallons of fuel, because every 100 miles is 1 gallon. I guess I should show how I got that. I took the 6907.9. We divided by 100. We got that. So we took our distance, divided it by our miles per gallon, because we're trying to find out every 100 miles is 1 gallon. Well, there were 6,900 miles in here, so we'll need 69.079 gallons of fuel to travel that distance. Okay? So that was a complicated problem. We had some big ugly numbers in there, numbers that barely fit into the calculator, but we square rooted, we got our answer, we were able to figure out how many gallons of fuel we needed, we got it. Letter D. Ooh, we're back to this problem. It says, using the map from example B, and I have it here for us again, how much closer is your friend's house, how much closer to school is your friend's house than your house? Go ahead, pause the video, try this problem on your own. When you're ready to continue, hit play, and we will go through it together. Alright, so we're trying to find how much closer. That is a difference. That is a subtraction. So what we need to do this subtraction is we need to know the distance from your friend's house to the school, and we need to know the distance from your house to the school, and then we're going to subtract them. So friend to school, friend to school minus your house to school equals the answer we want. Alright, so now we have our goal. We need to find out the distance from your friend's house to the school and your house to the school, and that will give us our answer. So let's do them one at a time. Your friend's house to the school. Well, given the pretty picture, I'm going to draw the right triangle in here. There and there. 1, 2, 3, 4, 5 here. 1, 2, 3, 4, 5, 6 here. So that gives me a squared plus b squared equals c squared. I do not know the hypotenuse. I know these sides are 5 and 6, giving me, that is 25 and 36. No, that's not 25. Yeah, it is. Equals c squared. And that gives me 61 equals c squared. If I square root each side, c equals, clear, 61 square root 7.8. Alright, so we just found the distance from your friend's house to the school is 7.8 units or miles or whatever distance that is, whatever label. Now, your house to the school. So we have this. We have 1, 2, 3, 4 here. 1, 2, 3, 4, 5, 6, 7 here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Alright. So I double checked my counting, and we'll make this C as well. Since that is the hypotenuse, because we have a right triangle. A squared plus b squared equals c squared. I've got 4 and 7 and c. That gives me 16 and 49 and c squared. That gives me 50, 65. And I square root each side. Clear. Just let me double check that. 16 plus 49. Alright. And then I square root it. Gives me 8.06. So the distance between your house and the school is 8.06. And if I subtract them, I will get my answer. Now, put the bigger number first. I'm going to flip-flop these two so I do my proper subtraction. 8.06 minus 7.8 equals, calculator says, 8.06 minus 7.8 equals 0.26. How much closer is your friend's house, or to the school, is your friend's house than your house? The answer is 0.26 units closer. So you see how that multi-step problem worked? I figured out what I needed for an answer, what I needed to do to get the answer, and then what I needed to do to get those parts. Your friend's house to the school, your house to the school, find both of those answers, plug them in, get the answer, and I'm good to go. If you could please, in the summary box, answer this question. In your own words, describe what the distance formula is and how it's used. Go ahead, pause the video, do that right now. And here's what I said. I have here the distance formula is just the Pythagorean theorem that has been rewritten. It is used to find the distance between 2 points on a coordinate grid. This has been lesson 2.6. Thank you for watching.